everyone, welcome back to Structure Expert. Today we continue to analyze and design steel beam in Tekal tense. Now let's start. After you click open Tekal tense, and you can select for tense and 10 forwards. Now I click tense. We will compare analysis and design result with my previous tutorial about steel beam I section 240 IPE section. We use the European standard section to analysis and design. Now after open software, you can create the new project. In one project contain different documents. Now click on new. Yes, you can create the new project. Let me call it the project is European. Yes, E. Click on it. EU steel. Okay, the project. One project contains this different document. Now I can add document 1, 2, 3, 4, 5 in one project. Click on new document. Okay, click on all. You can select all. Tekal 10, your own calculation, 10 calculations. So it's import. Yes, it's import in the right size. Now let me click on so it's import, and for all module here you can select which one you want to design. Now let me click on steel. Okay, steel, because we use the setting in the European, so design code also in the European. Yes, click on steel and steel beam analysis and design. Click on steel beam analysis and design. Double click. Now let's start from analysis and design in Tekal tense, and then we compare with design manual and other software to compare each other. What is the big difference between the software? Okay. Now click on the rate. Okay, the rate letter. You see geometry and combination. So you have to define geometry and load combination. Now click on geometry. I change the span from 8 meter to 6 meter. Okay, and restraint. Yes, we keep it in default. Click OK. You can change restraint. Click OK. And loading, you can check about the loading. The first and default loading is the same as the types permanent and load factor 1. Now let's create new load. Add full. Yeah, add the full on this beam, and the load is the permanent, and I change it to 5 kilonewton per meter length, and add the load type is variable like load, and also full apply full on this beam, and the magnitude of load is 5 kilonewton per meter length. Yes, we can define load class. 1 default is the permanent and variable, and you can add to 3. Now let me just show you how you can add 3, 4. Yes, you can add other load class. Now I want to keep it in default. Okay, in default. I don't want to add it. Okay, click OK. So you have to define. Now I want to delete it, also can delete. Yes, now let me click on concept, click on loading. I type it again. This is for the load file, and add for the line load file. Now click OK, and click on load combinations. Yes, you can add description, the permanent for the dead load 1.35, the safety factor for dead load and safety factor for light load. Click on OK. And the section, we select the section. Now click on the I-beam IPE 240, IPE 240, click select, and still click change to 255 megapascal. And here this is the preview result, the bending moment, kilonewton meter. This is the analysis result, 86.2. Yes, 66 is the MAD, the analysis result, moment result, and the capacity 86.2. So the ratio is 0.765. Utilizations. And see force deflection. Now let's click on output option. In the output you can click on full or summary. Now let me click on full, click on all the output. Okay, click OK, and let me click finish. Yes, this is the full output report in the Tekal 10 design IPE 240. Yes, 240. Now let's check the result. Let me seal it. Seal. Keep it in my sharing tutorial. Create a new folder, Tekal 10, and I call it steel designs. Yes, IPE 240. So now let's check. In accordance with N 1991-2005 incorporating UK national knowledge, and the span length is 6 meters. The permanent load and variable load, the distributed load is 5 kilonewton per meter length. Load envelope combination. This is the result of the bending moment, and like the result is 66.0. The actual value is 65.954. It's round to 66.0. And the maximum bending moment at the middle span. And the shear, the maximum shear is 44.0 kilonewton. Now let's check about support. Yes, it's okay. Save it. Include save it. Yes, run analysis result and deflection. This is the section of the steel beam. And classification, class 1, and this is the design result. Now let me show you about the design result. Check for the MCOD. MCOD is equal to MPLOD for the moment capacity at the plastic. Is equal to the WPLY at the plastic multiplied with SY design yield strength of steel divided by gamma M0. Gamma M0 is equal to 1. So the moment capacity of the steel section is equal to 86.2 kilonewton meter. This value is not include LTD. It not include lateral torsional buckling. It is designed in the section. Yes, the section, not the section receive pressure and shear. Yes, this one for shear, the design shear force, shear area, and design shear resistance. And the check bending moment about measure assist according to section 6.2.5. Now you do not see the result of lateral torsional buckling, so the design report is not include lateral torsional buckling. It designed for the capacity to receive pressure only. Yes, not include for the lateral torsional buckling. Now let me seal. Okay, and we create other new documents. Now let's click on steel again and click on member design. Okay, member design, click calculate. Sorry. In one project contain two different documents for IPE 200 steel design. And now let's check steel member design according to the zero code 3 UK national NH and the version of Tekal 10E version 4.4.08. Now you can select the design bending moment 66 and design shear 44. We take the result from the about report. Now include the analysis result to this section and now apply axial force. This beam only see for the pressure and we design for the LTD. Select section. Now let me change the section to IPE 240. Okay, this one is correct. Click OK and change the steel grade to 235 megapascal. And lateral restraint, now I input 6000 in both axes. Okay, for the torsional restraint we keep it 0. Click on the preview before you continue to output the result. Now if I do not click on the preview, let me check. Okay, finish. You see the alert message. Preview result must be enabled before proceeding. So you have to click on the preview results. Now you see here the shear resistance. The utilization is 0.169 and the bending resistance about y-axis. Yes, y-axis and z-axis. The capacity is only 31.7 kilonewton meter and the applied moment is MED is equal to 66.0. So the utilization is 1.583. You see this value is lower than the design menu. The design menu it is set is around 1.7. So what is different? Now let me come back and compare with the set again. Click on design steel texture and steel beam design for pressure and shear according to 0 code 3. Okay, now Now let me click on steel beam design procedural and CA003. Okay, this is the steel beam view IPE 240. And now let's change. Yes, pin distributed load is correct, and the apply moment is 66 is correct, and apply C4 is correct, and the steel strength is correct. And now let me change to 6 meter is correct. So decay we apply at the top. Okay, the load is stabilizing loads. MCO is equal to 32.1. Now let's check with the design result. Okay, it's gamma M0 1, gamma M1 1, gamma M2 1.1. Yeah, still grade is correct. Check for the shear, design shear4, design bending. Yes, and elastic critical moment MCO is equal to C2 multiply with the L buckling load and multiply with this term is equal to 45.2. So here the result is 42.1. In Tekal 10, C1 is equal to 1. Actually, the value is C1 is equal to 1.132. Yes, it depends on the support condition. It depends on the moment shape. Okay, moment shape. So in the class, use the class 10, use C1 is equal to 1 and KC is equal to 1. Now let me check the KC. Change it to fit pin. Yeah, KC is equal is 0.94. Okay, 0.94. What is different? And lambda LT bar greater than lambda LT bar 0. Lateral torsional buckling cannot be ignored. That's correct. Now let me check with my report. Yes. So we had to check about the LTD. Okay. Now let you compare with. Now let me save it. Okay. Still it to IPE 240 LTD. Lateral torsional buckling LTB. I'm sorry, LTB. Okay. Now let's check on the result. When you click on the analysis and design beam, so in this design report is not verified with LTD. It designed for the flexural and shear only. Now, when you design for the section, it include to check for the LTD. Yes, lateral torsional buckling must be included in the case. So you can check here the MBYOD is equal to 41.7. Now let me check. Here the result is only 34.7, so it's a difference. Yes, it's MBOD is equal to 31.7. MBOD, yes, 31.7. And for the section only, yeah, this is for the flexural, the capacity is 0.77. Now let me check the ratio. You can come back to calculate and preview the ratio. Yeah, the ratio is 0.765. You see here, 0.766. Okay, is correct? Yes, is correct for this result. So when you analyze and design in Tekal 10, it's designed for the bending, not include LTD. Yes, sorry. Click calculate again. Click finish. Now let me click on the LTD and check with the LTD. You see here the buckling curve IPE. Now actually our buckling curve is A. Yes, it is. We design to the general approach. Okay, general approach. And for the B, in terms of the equivalent by dissection. Now let me check the curve buckling table 6.5b, friction factor, correct factor for rule section, LTDs, and LTD reduction factor 0.4, yes, 0.46. Result is 0.4h. Modification factor, the modification factor F is equal to 0.99. Yes, it's similar with bond. Modify LTD reduction factor. Design buckling resistance. Lambda LTD multiply WPY multiply the SY divide gamma M1 is equal to 41.7. Now let me check. So the final result is 39.7. 39.7. So we compare with the equivalent by dissection. Yes, 31.7 and 39.7. The ratio, you can check the ratio. Click on the calculate again, and the ratio is 1.58. Now let me compare with my calculation is 1.66. Why it is different between the result? Now let's check the design option. In Tekal 10, you had to define about stabilizing load. Yes, I also define in my Excel. When you apply, you had to know about the apply load. This is the stabilizing load or stabilizing load. The load type applied at the top or at the center or at the bottom of the flange. This is also impact on the result. Now let me change. In the default, this area is not designed destabilizing load, so we click on stop destabilizing load. So the factor for destabilizing load, you can select it. Now let me select for the 1.2 and click OK. You see here the bending resistance is increased to 2.093. Yes, 2.093, and my result is 1.66. Yes, it's 1.66. And for the shear is 0.169. Now let me check for the shear. Yes, it's for this divide this value. Yes, it's 0.19. Yes, it's the same, 0.169. Is correct. And be careful when you use the Tekal 10 show you. When you design, check in the design option. You have to activate the stabilizing or destabilizing in the case you untick here. So this section will be your stabilizing load. What does it mean when you apply stabilizing and destabilizing? Destabilizing is mean that the structure no lateral restraint to prevent lateral deformation and rotation of own axis of this beam. It's freely deformed when apply the load at the top plane of the beam to increase and to decrease the moment capacity. If we compare when the load applied at the shear center and condition of load is stabilizing. This is the way you can check with the software and how you can verify with the design menu. This is very important for structural engineer and for designer to check it. Now let me activate the same. So you see here is the value for the vector, value the minimal value. So the final design value is 2.09. Yes, it over too much. Okay, it's compared with my design. Yes, it's over 10, just 10%, 11%. Now let me come back and untick here. I assume it work in the default is a stabilizing load. Click OK. And design result is 1.5 H. Okay, now let me change my it's a to stabilizing load, and when you apply the stabilizing load, you should select load apply at the shear center, because we do not consider the distance ZZ. Okay, ZZ is 0. We assume it apply at the shear center or the section. We design for the whole through section. Okay, the shear center and center gravity or the IPE is the same equation, so ZZ is equal to 0. Now let's check about the relationship. Yes, the relationship 1 is 1.62 and relationship 2 is 1.44. Now let me check. Yes, 1.50H. You see here, this similar, this one general approach. Now let me check it, the design option. Okay, you can check for the slenderness correction vector. Now let me change it to 0.94, 0.94, and click OK. Yes, you see here. The final design result is 1.433. Yes, it's the same. It's 1.44. Yes, it's the same. It's 1.43. When you use the European software, you should know how to design it manually, how to input the data correctly. This is very hard when you want to design one section correctly according to the codes. So you have to know everything from the code and recommendation and the vector to apply here. Yes, the vector for the lateral torsional buckling, stabilizing load or destabilizing load. The defined vector, you can change it in the default for the partial stability vector of steel, gamma m0, gamma m1, and gamma m2. You can change it manually and design based on the European and the national net. You can national net, click OK. You can click finish. Now let me check. Yes, 46.1 for the MBY. Yeah. This one is 46.0. it the same. Yes, it's the same. And for the MED design ratio is 1.433. Yeah, 1.44. Now let me check it. Yes, 1.43. The result is the same. And for design bending moment is it design buckling resistant moment. Now let me see it again. This is how you can check it. I just want to alert you when you use this software, how you can correct it, how you can use the option. This software is very good. When you design and verify it, you can use this to verify with Tekal structural designer or with a tape with SAP. It is easy to use, but you have to use the correct parameter to make sure the output is correct. Yes. Thank you for your watching. I hope you enjoy the tutorial. Let's share and subscribe my tutorial channel. I will upload more tutorial to discuss each other, and you can comment below in my comment. I will reply you what you want to know about the structural design, about the steel design or concrete design. In my channel, you can comment and ask me about the reason. I will explain you later in my group or explain you directly in YouTube channel. Thank you for your watching. Thank you.